Okay, now we're testing the integrator with the initial condition, and because we're using a summing amplifier that's inverting, that changes our integrator to non-inverting. And what I've measured is the maximum voltage, which is 4, and the minimum voltage, which is -5, and that matches our LT Spice simulation. So rather than going rail to rail, the positive rail, there's actually a volt subtracted. I did have to adjust the bottom power supply so that the minimum was coming out closer to 5. That's not too much of a problem. And the initial condition is sensitive to the power supply voltage. So maybe if I were to make this circuit more reliable, I would use a voltage reference and go from there rather than depend off of the raw power supply voltage. But I'm measuring a fall time of 35.38 milliseconds. And so if I just take the peak to peak, which is about 9 volts, multiply that by 0.8, that gives me my 10% off of the top and the low transition. And then divide it by the fall time, I get a slope of 205 volt per second, which is, again, pretty close, or certainly within 20% of our predictions. The other thing you can notice now is that when the voltage is high, our slope is going up, and when the voltage is low, our slope is going down. Now, just to reiterate, if I speed this up, right, I'm not going rail to rail, and that'd be okay. You can still just go it's probably all right. You just go from the high to the low, and still whatever that peak to peak is, now it's like 4.9. Multiply that by 0.8 and divide by the fall time. It should still work, but when it's going rail to rail, you can really see what's going on. But it's good though that I've testing this bit by bit, because I thought that this blue line connecting ground was connecting ground to the V plus of the second op amp, and it wasn't. And boy, was I getting some weird results. So if I had assembled the whole circuit, it would have taken me forever to find that mistake. What I thought I'd do as well is I'm going to lower the negative supply, and you can kind of see what you get. And in fact, notice what you get when there's no power. We've all done it, right? We're getting some weird shape, right, with no power to the op amp. So this is putting the negative supply back to 5 and the power supply back. See how it goes really back to 5. So you really want that positive power supply to be 5, because your whole initial condition is based off of the power supply. And there you go, there you have it. Next stop, the multiplier or the Schmitt trigger.